Hello everyone, this is Chris. I work on SeaweedFS. Here I'm going to cover some recent changes in year 2025. This is a GitHub star graph for SeaweedFS. SeaweedFS actually started on 2011 and moved to GitHub on 2014. Now it's 2025, so there are a total of 14 years altogether since the very beginning. And there are a lot of bugs and fixes along the time. For SeaweedFS, performance and scalability are two most important things we spend a lot of time to develop. And we do support S3 features, but we focus on mostly the simple ones, not more complicated enterprise features until this year. Today I'm going to cover more advanced features for S3, which includes server-side encryption. There are three kinds of server-side encryptions, and also object versioning, object lock-in retention, and support for advanced IAM systems, conditional operations. I will also cover some performance improvements. Beyond S3, there are some new features under development, which is some message queue and support for Kafka. There will be questions and answers later. For server-side encryption, there are three kinds of server-side encryption you may want to use. The differences are how the keys are managed, whether it is by external KMS systems, or by customer, or by SeaweedFS itself. There's, of course, the use cases will be different also. These APIs are 100% S3 API compatible with AWS, and also they work with all existing S3 clients. There are no code changes required except some configuration. The simplest version of server-side encryption is SSE-S3. Basically, it's managed by the server. SeaweedFS manages all of the keys. There will be automatic encryption and decryption, and bucket default encryption support. There are no configuration required. The example is you can see from the right side. When you're copying using S3 commands, you just specify server-side encryption using AES 256, and that's it. This is the simplest way to ensure data is encrypted at rest. So if someone take the file but without the metadata managed by SeaweedFS, they will not be able to understand what's in the file content. The encryption will also be very fast and high performance. The workloads can be a lot, and the encryption will be very fast still. It's ideal for logs and backups or some large amount of data to encrypt. The second, a little bit more complicated, is using external key management system. There are several kinds of KMS providers: AWS, Google, open source ones. The way to use it is you can specify the server-side encryption as AWS KMS, and also the SSE KMS key ID. External KMS are usually required for compliance, where you can get sophisticated audit trail for every decryption or fine-grained access controls. where in a multi-tenant environment, the keys for each customer can be different. For more advanced use cases, customers may want to use their own keys. This is where SSE-C will work. Basically, you can bring your own encryption key, and the key will be just sent via HTTP header during runtime for each request. They are not stored on the server. This gives you full control for all of the compliance requirement. On the right side, you can see there is an example where you can generate some random file and then use it during the encryption. This is for use cases where you want to fully control the keys, maybe generating using or encrypting using the external hardware security module, or governmental or financial use cases where it needs very strict security requirements. For SSE, there are some technical details. The encryption and decryption now fully support native FIPS 140-3, which is Federal Information Processing Standard Publication 140-3. This is U.S. government security standard that required for cryptographic modules. It's actually natively supported in Go 1.24 plus. For another thing you may want to know is the range request will still be working very efficiently, and it works with all of the SSE types. This is because it is using AES-CTR, basically AES in the counter mode. It enables block aligned seeking. So for any range request, it can go directly to the position and pick the encrypted content and decrypt them. It can support multiple range requests. The copy operation will still work efficiently across different modes also. There are some technical details, but you can safely assume everything will work fine there. Object versioning is another important new feature. It can protect against any accidental deletions. How it works is you will keep multiple variants of an object, and you can easily retrieve any previous versions. For deleted objects, the deletion will be represented by a deletion marker. This is how the storage layout will look like. For any file that is not version enabled, or if the bucket versioning is paused, it will be stored as is. But if the file is versioning enabled, the file itself will be represented by a folder, and the multiple versions will be stored as v dash some number. There will be multiple versions. The latest one will be referenced by the directory object itself. The metadata will point to which version is the latest. Object lock is another important feature. In many regulated industries, they are required to be write once, read many objects. Object lock basically can prevent any deletion or modification for a period of time. There are many use cases for financial, healthcare, legal, or ransomware protection. and especially for backups. Object log has two retention modes. The first one is governance mode. Basically, it will protect from most users unless bypassed with some special permission. It's usually good enough for internal compliance. When you're using it, you just specify the retention mode is governance, and retention will retain until a particular date of time. The second retention mode is a more strict mode. It's called compliance mode. Any objects that's in this mode cannot be deleted by anyone, including the super user. The retention period cannot be shortened. It's usually required for regulatory compliance. When you're using it, specify the retention mode as compliance and a particular date of time. That's it. The third way for object log is called legal hold. It's a more independent protection mechanism. Basically, you can apply the locking on the object at any point of time, and then later removed at any point of time. During the locking, the object cannot be deleted. It's usually used for litigation, investigation, auditing. When you're using it, just specify legal hold status equal to on or off. SeaweedFS also enhanced on identity and access management. There will be more fine-grained access control, and in the newer versions, the bucket policies also supports AWS style, and the identity and resource-based permissions, and there will be dynamic policy evaluations. The IAM API also support a list of all of the APIs, and they are all compatible with AWS IAM tools. Another part of SeaweedFS S3 enhancement is more full support on the conditional operations. The if conditions in the headers are all supported. The most common use cases will be optimistic concurrency control or efficient caching and atomic creation. Basically, you can just check the objects if it is modified or not. For SeaweedFS, the S3 component have a very major architectural change. Before, S3 clients will go through the S3 API web server and then go to the filer, then go to the volume server for the data. After the change, the S3 clients will still talk to S3 API servers, but the S3 API server will only talk to filer about the metadata updates, reading, writing. The actual file content will go to volume server directly. So this way, the actual file content will never go through the filer itself. This way, the filer will have much less workload. Previously, ideally, you will be having S3 server and the filer as a one-to-one. After this change, you can have many S3 servers and a few filer servers. Another benefit is that the latency will be much lower, especially for write latency. In some use cases, the customers report there are 30% reduction in terms of latency. By avoiding the buffering layer in the filer, the overall throughput will be much better. The above are all about S3 features. For SeaweedFS, I also gave a lot of time to think about what are the next development direction for the future. Maybe in the future in the range of 3 or 5 years. Here's what I think, but you guys may have other suggestions. I'm all welcome to any ideas that you may have. Here's what I think. For SeaweedFS, basically right now it can support unstructured data very well. For example, the files, whether it's small or large, and different ways to access the files, such as S3, Hadoop, or Fuse Mount, and many other protocols. But for structured data, SeaweedFS can also be a very good destination. Think about this way. The data can flow into SeaweedFS as messages, and those messages can be converted into Parquet files and act as big data tables, and with many files and also data tables, it will become a data lake. So for this idea, I started to implement some basic components for this. The first one is a message queue, which can support structured data. The messaging will be purely schema based. Why we need a schema based structured messages? This is because we can enforce the schema validation, and the data can be converted into Parquet files in a columnar format, and also the messages can be queryable just by SQL, so we can support basic SQL syntax. Here's one example. If you want to store user events, you can just define the struct and also the schema. Basically, you can say the schema record type has fields user ID, action, timestamp, and metadata. This is a schema, and you can publish and subscribe to the messages. All of the messages will be converted into columnar format and stored as Parquet files on the SeaweedFS. The messages will be queryable by some basic SQLs. It can support some basic SQL that you can push down some basic filtering or do some calculation. Say, for example, the top users or in the most recent times. The message queue can also support Kafka. Basically, we're acting as a Kafka gateway and support all of the existing Kafka clients. It will have native Kafka protocol support. Your existing Kafka clients will work as usual, supporting all of the Kafka tools and support partition, topic and partition, and consumer groups. The data will flow from Kafka clients to the Kafka gateway and to SeaweedFS message queue. The data will be stored in SeaweedFS message queue in a row-by-row format, and later converted into Parquet in a columnar format. The SQL engine will be able to read the Parquet files directly. This is how I imagine it should work, and the whole workflow actually is already working. I haven't published the documents yet, on how to use it, but it's fully tested and it's already working. Okay, this is a summary for SeaweedFS in year 2025 December. The SeaweedFS has enhanced the enterprise features for server-side encryption with KMS or customer mode or S3 mode. For data governance, SeaweedFS S3 support object versioning, log and worm compliance. For access control, it has more advanced IAM with bucket policies. S3 also have much better performance improvements also. And beyond S3, there are some new message queue features supported in order to have a unified platform for S3 streaming and analytics. That's all for today. Welcome for any questions.
We have a question from Martin. How does it compare to?
I would say in terms of API support, also I think Ceph is also very good on supporting all of the. But in terms of and also this is much better. I think there are several benchmarks that's been done by real users. In terms of performance, SeaweedFS ranked like #1 in actually.
Append also to.
Go ahead.
Yeah, sorry, we just have some delays. I would like to also append an answer to this question. Really bad with tons of small files. SeaweedFS was designed to work with small files at first, but again, works fine with big files. But handling many small files, it is always good from perspective. Also, SeaweedFS is better at scaling. You can scale I/O horizontally. FS, it is possible just to scale by adding new replicas. Am I right, Chris?
Correct. For upscaling, you just add more volume servers. You can also, all of the data will be kind of rebalanced as when you want them to. And size of cluster, if you want to scale up, you need to kind of double and then migrate it. I don't know how exactly how it works, but it's not very flexible.
All right. Thank you, Chris.